This is Geometry, Chapter 10, Lesson 2. It begins on page 385. All right, so now going back to the same triangle that we looked at in Lesson 1, and we're going to apply some of the things that are taught in this lesson to the example that I began with, all right? So, how do we know that these triangles are similar? We know that they are similar because, as we said, their angles, remember we had labeled the angles, corresponding angles are congruent. Their corresponding angles are congruent. That is always true with similar figures. And the lengths of their sides are proportional, such that there's a scale factor that I can multiply the lengths of the sides by to get to the length of the side in the second triangle, all right? So if I were to say AC, the length AC over A prime C prime, it is equal to 2/5, though that ratio, right? This is your scale factor. You can multiply any of these. This is actually your ratio, right? This is how they relate. This side to this side is going to equal that side over that side. My preference is to write it as AC over CB is going to correspond to A prime C prime over C prime B prime. Okay, so similar polygons have congruent angles but proportionate sides, such that there's a scale factor or a magnitude. So these are interchangeable terms. The scale factor, that term that I used in lesson 1, is the same as the magnitude or this constant R that we can multiply a term by. So like 2 times some scale factor equals the 6. My ratio or my scale factor would be a 3. It would be a 3. So to get from the smaller triangle to the larger one, I multiply by 3. So that tells me that the second one was always a dilation, but it's a dilation of the first one. So looking back to our transformations, right? This is a dilation. Remember, a dilation is the only transformation that is not an isometry. With an isometry, we have congruence. When we have a dilation, we have similar figures, okay? So this is just a dilation. So if the second one is larger than the first one, scale-wise, then this ratio is going to be greater than 1, because I'm going to have to be multiplying that smaller side by a value greater than 1 to get to the larger side, the larger triangle, all right? Now, if I were going from the larger triangle to the smaller triangle, then my ratio is going to be a fraction. It's going to be between 0 and 1, okay? And I could do that. So the way we worked it in lesson 1, we worked it from the smaller to the larger. We know these sides, but we're going to work it from the larger to the smaller to show you that the scale factor is going to be less than 1, okay? Let's make this an even number. I guess it doesn't really matter. All right, 5, 15, 20. All right, and this is C and that is A. So notice that the angles are capital letters. The side opposite the angle is the lowercase letter. And that's the way all math textbooks label sides. They relate it to the angle opposite the side. Because remember, that angle really dictates the length of the side opposite it, because the bigger the angle, the side opposite will be larger. The smaller the angle, the side opposite that small angle would be smaller. All right. So what do I multiply? I'm going from the bigger one to the smaller one. So 5 times some scale factor to get to 2. Well, what's my scale factor? This is multiplication. I want to solve for the scale factor. I divide both sides by 5. So my scale factor is the length. If I'm going to the smaller one, it's going to be the smaller one over the bigger one. If I'm going to the larger one, it's the larger one over the smaller one. Okay? And so just note, engage your brain. If I'm going to the smaller figure, it's going to be less than 1. If I'm going to the larger figure, it's going to be greater than 1, right? It's logical, all right? So I can multiply 20. I can multiply 20 times 2/5 to get to this side. Okay, because these terms are multiplied, I can simplify. That's a Miss Haleyism. Simplify before you multiply. You can only simplify terms that are multiplied. All right, so simplify before you multiply, and you can only simplify terms that are multiplied. Crisscross. All right, so 5 goes into 5, 1, and into 24. 4 times 2 is 8. We already knew that side was 8. What's my scale factor? It's small. It's less than 1. If I'm going here to here, my scale factor is 5/2, right? It's going to be greater than 1. All right, now how do I go? I went from 20 to there. Now let's go from 15. All right, 15 times 2/5 is going to equal the side C. All right, so before I multiply, I simplify. 5 goes into 5, 1, into 15, 3. 3 times 2 is 6. That side is 6. All right, so all of my sides are proportionate. They have this ratio by which I can multiply them. All right, so all my ratios should equal. 2/8 should equal my corresponding sides, right? 5/20. 6/8, and these two are equal if I simplify them. 6/8 must equal 15/20. All right, that's 1/4, 1/4. Both of these are divisible by 2. That's 3/4. Both of these divisible by 5, 3/4. Okay, that ratio, those ratios should be equivalent, all right? So there's this direct variation, this direct scale factor, this constant that I can multiply a side by. What's key is I have to know my corresponding sides, and that is dictated by the angles, right? I can either calculate the scale factor, right? If I'm going small to big, it's 2 times scale factor equals 5, right? 2 times scale factor equals 5. Once I get the scale factor, I can do any side of the small triangle times the scale factor to equal the side of the large triangle. If I'm going the other way, all right, this way, my scale factor is going to be greater than 1. If I go the other way, the larger one to the smaller one, it will be 5 times my scale factor equals 2. My scale factor is going to be less than 1. So now I have to take any side of the large triangle times that scale factor equals the corresponding side of that smaller triangle. Or I can just use cross multiplication, right? By setting up corresponding sides, okay? Like I did in lesson 1. I can take the small triangle, I can take the large triangle. It's 2, 6, 8. Of course, one of these will be variables, right? And 5, 15, 20. Let's say that would be C, that would be A. If I'm solving for that, then I'm going to use cross multiplication, right? The scale factor is also your ratio, okay? It's your ratio. So it would be 2 is to C. I just go like that. It's kind of hard to see, isn't it? 2 over C equals 5 over 15 and cross multiply. Remember, you can always cross multiply when you have a ratio equaling a ratio. So this is 5C. My equal sign stays. 2 times 15 is 30. Divide both sides by 5. C is 15. When I solve for A, I'm not using my C value because I calculated that. So it'd be 2 over A. To solve for A, I would ignore this middle, and it's 2 over A equals 5 over 20. And I would solve for the C that way, okay? Or I would know my scale factor has to be, if I'm going small to large, it's 5 over 2. If I'm going large to small, it's 2 over 5, okay? All right, they're similar. How do we note similar? So you have a squiggly line. Triangle ABC is similar to triangle A prime, B prime, C prime. And we'll be doing a few proofs with similar to prove that triangles are similar. So remember, similar triangles, congruent angles, 3 congruent angles, but the sides are proportionate.